Okay, so you should now have a device0 class with member variables, constructor, set get methods, and a toString. You will notice that general pattern to classes, individual classes throughout this. Then you'll have in your week 21 test, you create your device, you display it, and then you change the name. So what we're now going to do is we are going to create this thing, the device manager. It'll hold an array of our objects. We need to create a constructor and add functions to it. But what we'll probably just do in this video is just use this constructor. And you can go back to the snippets to look at how to do the others. We will have an item method where you give it the index and it returns an object. You also have a set method, though this says item as well, and this takes an index and an item and will assign it to that or override it. That's almost an update. And you also have its own ToString method. Now in the snippets, this is quite condensed, so we need to unpack that and work our way through it. The other thing to note is that this test script, so if we rename this file where we call it week thing and just call it test1, and then we make a copy of that. So if you right click that and say copy, and then in the same folder hit paste, refactor copy, it gives you a chance to rename it. We'll call it test2. And so what we'll have is a series of test files which we can run separately. So then if we edit this one, this will be a different bunch of tests for test 2. Test 1 remains intact. Now the reason I'm encouraging you to do that is because in your coursework you have to do a similar thing. As you develop the complexity of it, you need to have a single separate test file which will pick out those features. So we need to create our device manager first. So we need an array of device objects, a constructor, and as I said, we're going to stick to the simple constructor and maybe one of the adds, but certainly the simple constructor for the sake of this video. You can follow through the code yourself and work out how the add works here, especially with this index. A little bit tricky. So let's go back to our project. Go to your default package, right click it and create a new class. We call this device. Technically it's devices manager, but we'll call it, my V is not so good, device manager. Okay, and let's finish that. So down here we have device0 device manager. Let's get rid of all of this so we can just keep it nice and simple. So the device manager, as we said, is going to have an array of device zeros. That's very important. And let's make it private, which it should technically be. I'm not sure if the snippet code has that. No, it doesn't, and the snippet code should have that as well. Okay, so we've got an array. At the moment, we haven't assigned anything to it. So let's create the simplest constructor. Double click the name of the class, public device manager. And what we'll do is we pass it an array, because what we'll do is we'll do a bit of work in the client in this version, and we will pass it from, I don't know, what should we call this? We'll just call this an array. Now, as someone has noticed, this particular mechanism has a few problems. And one of the problems is the fact that if you just pass in the array here, there's quite an important but technical issue. You should be very, very careful that your client, which passes in that, also has access to the data. So actually creates a little bit of an issue inside this type of code. For the time being, we're going to just stick to it. So what we do is we get our private member variable equal to array. Okay. just for the sake of setting something up quickly, but the recommended mechanism is the second one that we will use. So we'll come back to that in a second. We just want a very simple mechanism to populate it. It has technical issues because it means the client still has access to the array. So that's the first thing. We want to populate it. And then let's keep things simple at the moment. We want a ToString method so we can see, and we don't need that, so we can see what's inside that. And we'll build it up in stages. So let's have a public. We're going to return a string, and we create a ToString method. String, don't pass it anything, hit return. And so here we'll need a loop to go through the array. So what we'll do is we'll declare a string, and we'll create a variable called return value, which is going to contain the string. Create a loop, and in the loop set the counter to 0, which will start at the first item. It'll be less than the length of our array, right? And the array up here, if you see I highlight it, they all turn green. It's dot length. Of course, you can create a size method, but we won't worry about that for the time being. These are all things that you can do later. So that creates our loop. Inside our loop, we want to take our return value, add it for each item inside the array. That's how we access it. We use the index number, and we hit dot, and we get its ToString method. So what we're doing is that inside the device itself object, we have a ToString method which gives us all of that. So we're going to use that inside this string method to create it. So that will loop around, pick every single one that we have. What might be a good idea is we just create something like this just to separate out. Maybe not there, bear with me a second. You can play with this, right? Just to make sure that it's easy on the screen. When I was writing out the third in class test, I spent some time trying to work out how to do it. And then once we've done that, you see it's still complaining. We need to return the return value. Okay, so this should populate it, and this should tell us that what the populated version. We have no get set methods in here at the moment, but we're not going to look at that. Let's go to test 2, and in this test we're going to adapt it. We had a first device created, so let's just create a number of different devices. For example, let's create 3. Let's give them different names: 0, 1, and 2. Let's make the second one a phone. Give it a different number. I don't know, 15. It's just a phone, and let's say a television, right? And we'll call that 5.678. It doesn't really matter. So we have device 0. We create 3 of them separately. Okay. We then have the option of creating an array of them, where we're going to add them all to the array. Now, looking at that, I'm suddenly deciding that's actually quite a clumsy way of doing it, given the fact that I'm replicating what I have outside. What would be better is I just had an add method where now I've created the objects, I can just add 3 of them, okay, to my array. So let's just simplify. Let's add in that. So let's go public void. We go back to the device manager. We create an add method. And one issue here is that we haven't specified how long. We need to create another. We need to do 2 things. One is to create another constructor. And in this constructor, we specify the length that we need. So what we're going to do is we're going to pass in a size value. Close that bracket. So if you're watching what I'm doing here, right? So let's just get the names right. Okay, I'm going to pass into it an integer, which is a size. So this second constructor I've created, and you can see I need to just double click and get that name right. This second constructor will create a new instance of that array of that length. Okay, I'm not going to put any checks in. I'm just going to allow you to add, and we'll discuss how you might want to put some checks in, but we'll do that in a second. So what I've done is I've halfway through this coding abandoned my idea that I would create an array here and just pass the whole array in. It doesn't hurt to have this mechanism, but actually I want the work to be done inside here. So how would we add it? Well, to add it to the devices and the device manager is we need a simple mechanism to add to a particular location inside the devices. Now, here comes an interesting thing. To add to an array, right, let's say I'm going to pass in a single device, right, and let's just call it DVC. If I go to my array, I have a question. Have a look at this piece of code. Where do I put it in the array? How do I know where to put it? And how do I know I don't get longer than the length of the array? So we have a little bit of a problem. So what I've done, and you'll see this in the snippet, is I create a private variable called current index. We could actually even call this add index and see if that makes more sense to you, right? Private integer. And what we do is once we've added it, and what we do also is set it to 0 when we create the object, okay? So once we've added it, we're going to take our add index and we're just going to increase it so it shifts to the next one. And in theory, we should be able to put our add index straight in there. So what this does is that when I create the object out of the device manager, it sets this add index to 0. When I call add, I pass it this, it wants to assign it, this will be 0, the add index. After I've assigned it, it increments it. Now the only risk to this method, I don't know if you can spot it, is that I could keep on incrementing it and go outside the length of my array. What's stopping me from my client just adding 4 items? I'll show you what I mean. If I come back here, right, if I squeeze up here, let's create a device manager object, and I keep on capitalizing that second, and let's call it dvmgr. I'm going to create a new one of those, right, and I'm going to pass it, say, 3. So this line calls in my device manager this line here, and it creates this size. It doesn't call this constructor, it's completely different, right? So now in my test2, I've got a device manager which can hold 3 items. But if I accidentally added a 4th one here, it would crash it. So for example, I've created 3, right? So what happens if I do this? dvmgr, call my add function, and I pass in each one, dvc0. Let's do each of those. All I'm doing here is I'm just adding, right? And when I add, ignore this, we'll come back to this later. Let me just comment this code out for the second, because this is from test 1, right? But what happens if I just created another device and tried to add it and had a 4th item, but I've only specified 3? I'm clearly going to break this code because this only expects 3 and I've added a 4th. So before I add, I should really check where this index value is. So if I have 3 items, add index needs to be 1 less than the length, right? So let's create a variable called upper limit. Just to make the concept clear, we get our devices, get the length, and we take 1 off it. Okay, so if it's 3, then the upper index, not limit, let's call it upper index, okay, can only be 2. If there are 4 items, the upper index takes 1 off, it can only be 3 because it's 0, 1, 2, 3. If it's 4, it's 0, 1, 2, 3. If it's 5, it's 0, 1, 2, 3, 4. So it's always one less. So that gives us an upper index, right? So I come into the add and I just do a check. I find out what the upper index is. So I quickly ask, how long are you? Array, take one off, and then I do a quick check. And if this check fails, I would just return and not proceed inside this. So these lines won't execute and we won't go into them at all. So what's the check? What I want to do is I want to find that add index. If add index is greater than the upper index, then I know I'm going to be adding one more that I can afford, right? Different ways of making that line. But this basically is a line which exits the code if that condition is true. So for example, if I try to add a fourth item, right? So that would equal 4, but it would be greater than the upper index, which for 4 items will be 3. Check the code yourself, code that, right? Have a look at how that looks. The version in the snippet has this logic, which is pretty much the same, but I've just written it slightly differently, hopefully a little clearer. So what happens is it just exits. It doesn't add the item, so that it stops your code from crashing. Now that's one mechanism. You think about what the implications of coding it like that are, whether that's good, whether that's bad, and so on, when you do come to coding it. So now I have an add method that's reasonably safe. Let's go to our test. So if I create a fourth item, right, just for sake of argument, let's see if I can break my code. And let's just call this my not phone, not my thing, my tablet, right? And let's give that a different number just for the sake of it, and let's try to add it. So it's dvc3 inside of my client code. So I've only said I can have 3, so that means 0, 1, 2. I cannot have that fourth. It should crash. So let's see what happens. And it didn't crash. Oh, well, it won't crash. Let me just correct myself. It won't crash because it won't add that fourth item. It just simply will stop. That line would just return and not do anything. Now, and that's because of that code. If that line didn't exist, right, let's see what happens. Now it should crash. There we go, exception, blah, 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 blah. So what that means is that you're trying to add an item where the index has gone outside the length of the number of items you have. Okay, but there's a disadvantage to this mechanism, and you should think about what that is. If you call a piece of code and it doesn't do anything, how do you know it's not done anything? It's a bit of a problem. All we're doing with it is just safety, just to make sure we don't crash our code. Okay, just create a limit. Anyway, let's get back to the thing. I've added 3 items. I now want, what else did I create in here? I created a ToString method. So let's test that. So we can do a print statement. And instead of an individual one, our device manager is that. Press dot, ToString should display all the items. So let's run that and let's have a look. It's all kind of slightly cramped up, but it's accurate, as you can see from this information. Just verify it, change that number there, and run it again so you can see that that's accurate. Yes, it is. Let's change that again. Just have a look, and you can see that it's being added. If I change that television to a tablet, you can see that it's storing all that information. Fine. What's missing in this presentation is it's all rather cramped. So what you might want to do is create one of these lines inside here. So if I do that, watch how it just changes the presentation. Just gives you a nice little space. Actually doesn't do such a good job. It's a little bit messy. I do spend some time doing this. Let's run it again and have a look. And you can spend some time doing it so your presentation is a little bit tidier. So you can see them separated out. Okay, and I tend to do that inside the ToString method. And it's up to you how you want to do that. this ToString method does kind of assume we're dealing with a console. So it's a little bit of a compromise concept. Now, let's say I want to change one of the items in my, let's say this second item, which is at index position 1, 0, 1, 2, is at 1. I want to change that number there. How do I do it? So let's go back to here. I want to get hold of, it's going to be device. So if I just create a temporary reference to it, I want to say to DV manager, pass it a number, an index value, ideally 1, right, which will correspond to 0, 1 with the phone. And I want to hold it in there, and then inside there I want to do temp dot set value and change the value to, I don't know, 47.99, for example. Okay, but at the moment I have no method. Let's just do the dot, sorry. I have no get method. So let's create a get method or an item method. So that's how you add it. Let's do the reverse. So we go public. The return type is going to be one of the objects. So it's going to be a device 0. That's the data type. And I'm going to create a method called get. And I'm going to pass it an integer index. Now look how this code works. I go to my array. I pass in the index. Now remember, if you give it an incorrect index, it's obviously going to crash. And I just return whatever's inside it. Okay, looks nice and simple, but actually you would need to check there is a valid index and someone hasn't just passed an index in. Actually, truthfully, you need something like this in order to stop it from crashing. You need to do something like this. Is the index that I've just passed in, right, greater than or equal to the length of the devices? If it is, then you're kind of broken outside of the boundary. Let's just check. Maybe it should be equals, greater than. Nope, not happy with that. What have I done? What have I done? What is it complaining about? Int cannot be converted to Boolean. If index, which is a number, is greater than or equal to the device's length. Now, why is that a problem? What am I missing in this code? I want to return out of here. What did I do here? Index is an integer. If index right bracket. I think I've got too many brackets here. Hang on a sec. Let's get rid of that for a second. Pop that in there. Right, and then write in here return. There we go. Nope, not happy with that. It's complaining because it's expecting a whole object. So actually you want to return null technically. Now that in itself would have a problem for you. And look at the way that I didn't spot the obvious return type when I was going through this video. You don't just return out of it, because this is void return in the add. In this one, it's returning an object. But if you don't want to return an object, you have to return null. You can't just put the return word in. Now that will create its own problems, because when you come here and you specify, I don't know, 4, right? And we've got a method in there called get. Okay. Let's put a breakpoint in here. You'll notice it will crash when you try to set a value on it, because it's crashing because there is no object here for us to do that line. So actually that's not the best mechanism. And perhaps what I would recommend is for you to think about how you might want to do it. For the time being, I'm going to just assume you're always going to give me the correct index. And then just return it. Okay, that's just a bit lazy, but for the time being, for the sake of argument, that should be fine. Right, so let's go back here, and I want to return 1. So I'm returning the, that's gone from this screen over here. I'm going to set the value there, and I'm going to print it out. So let's have a look. But I need to contrast it. So if I put a print statement before I do that get statement, And let's see what happens. Right, let's run it. So there, it's difficult to see, but that is my original. So actually what I do want to do is print something like this, updating in here, just to make it clear in my output. Oh, didn't like that because I left out the semicolon. Right, let's run it again. Right, there's the original, it's updating. So look at the one I've updated. And it updated it for me. So all I needed to do was get the item, but it doesn't remove it. It gives me a reference. So this holds a reference to the item and it's still inside the array. So it doesn't eliminate it and I don't have to put it back in. I can then do what I like with it. And then you'll notice it updates it, which is that value in the middle, right? Let's put one of those in there just to make the presentation a little bit clearer. There we go, it's updating and it does that. So that is the end of this second video. It presents to you a basic device manager, how to get a get method, how to add an item, the issue of adding items and not going outside of the boundaries, a ToString method, and another constructor which we didn't use, but you can, and it's a perfectly valid mechanism. What else do I have in my original one? Same thing, I've just used different names in the snippets. So that takes us to the end of composition. We can add items, store them inside our manager class, a manager object. We can get them, we can edit values from within them using this type of mechanism. But now we're going to, in the next video, introduce a new concept, and one which has mixed but very important value and significance for this type of coding.